morning, sir. Myself, I am KM Sayurna. I am from Tripoli. My roll number is 244G1A. Today, my topic is fuel cells. Fuel cells, understanding the construction and functions of H2O2 and CH3OH minus O2 fuel cells. Number 1, fuel cells basics. Definition of fuel cells. Fuel cells are electrochemical devices that convert chemical energy directly into electrical energy through reactions between a fuel cell and an oxidation. This process is highly efficient and minimization pollution, making fuel cells and a promising technology or for clean energy. Types of fuel cells. Various types of fuel cells exist, including proton exchange membrane cells, solid oxidation fuel cells, molten carbonate fuel cells. Each type has a specific operational characteristics, materials used, and applications creating to different energy needs. Applications of fuel cells. Fuel cells are used in a wide range of applications, from portable electrochemical devices and vehicles and to stationary power generation system and backup power supplies. Their ability to produce clean energy makes them ideas for reducing greenhouse gas emissions. Number 2, H2O2 fuel cells. Construction of H2O2 fuel cells. The H2O2 fuel cells compares an anode, a cathode, and an electrolyte. Hydrogen gas is fed to anode, where it undergoes a reaction to produce protons and electrons. The protons move through the electrolyte to the electrode cathode, while the electrons flow through an external circuit generating electrolyte. Working principles of H2O2 fuel cells. In the H2O2 fuel cells, hydrogen oxidation occurs the anode, producing protons and electrons. The protons travels the electrolyte, while electrons travel through an external circuit, and cathode oxygen interacts with the protons and electrons of to form water, completing the electrochemical reaction and generating electricity. Number 3, CH3OH. Advantages of H2 fuel cells. H2O2 fuel cells. H2O2 fuel cells offers high efficiency and low emissions, making them environmental friendly energy sources. Number 3, CH3OH minus O2 fuel cells. Construction of CH3OH minus O2 fuel cells. The CH3OH O2 fuel cells further an anode, a cathode, and an electrolyte mentioned is used as the fuel, which is oxidized at the anodes to produce electrons and carbon dioxide. To design the tailored to handle methods mentioned while maintaining high energy conversion of efficiency. Working principle of CH3OH minus 2 fuel cells. In the CH3OH2 fuel cells mentioned, oxidation takes place at the anode, generating protons and electrons. The protons passes through the electrolyte to the cathode, while the electrons flow below through an external circuit, creating electricity. Advantages of CH3OH minus 2 fuel cells. The CH3OH minus 2 fuel cells advantages: usually liquid mentioned, allowing for air storage and handling compared to hydrogen. Number 4, comparative analysis. H2O2 versus CH3OH minus 2 efficiency. Both H2O2 and CH3OH minus fuel cells boost high efficiency, but H2O2 generally offers better overall performance in terms in energy output and conversion routes due to their high energy contact of hydrogen compared mentioned. Cost analysis. The cost of H2O2 fuel cells can be influenced by hydrogen production methods, while CH3OH minus 2 fuel cells may offer lower internal cost due to availability and ESS method production. However, operational cost can vary depending on fuel prices and efficiency. Environment impact. Both fuel cells types contributes to reduces greenhouse gas emissions. H2O2 fuel cells emit only water vapor, making them externally eco-friendly. CH3OH-2 fuel cells, while also cleaner than fossil fuels, produces carbon dioxide as a byproduct, but do so at a reduces level compared to conversion of computing energies. Conclusion: fuel cells such as H2O2 and CH3OH-O2 produces performing alternatives of to conventional energy sources. Thank you.